We live in a changing world. Humankind is developing with a speed our planet haven't seen before. But all this industrial growth leads to the inevitable trade-offs. Global carbon has been rising drastically over the last decades. Plants and bacteria are the only living organisms on our planet that could stabilize this situation by reducing these amounts. Plants absorb CO2 in the process called photosynthesis. Using the sun energy and water, they produce sugars that they can use for their life. As a byproduct, they produce oxygen that all of us breathe. But plants are not just factories cleaning the air from CO2. They're living creatures exposed to different stresses and a bunch of different factors. So when we complain of having no snow for Christmas or extra hot summer, plants can also feel that, and they change photosynthesis so we can measure it. We could put our scientific devices on one leaf, but can you imagine how many leaves there are in the forest? What if we want to measure the whole forest? What if we want to know how much carbon dioxide went inside the forest or came from it? So one way to measure it is called eddy covariance. Eddy is not a name. It's those swirls that appear in the air when the air meets any obstacles on its way. As CO2 cannot fly on its own, we assume that it's moving with air and its eddies. So we can use this idea in mathematics and calculate in numbers how much CO2 has been eaten by our forest or it was released. To measure the whole forest, we have to go really high above it, so we need to build a tower. A station for measurement ecosystem-atmosphere relations has been built in Yarselia to study different processes happening in the forest. A huge tower with two eddy covariance systems stands in the very heart of the station. So how could we use this data? First of all, we can calculate the budget. We can know how much CO2 went inside the forest in the year or came through it. But also, we can look what is the impact of our forest to the whole global picture, to the global carbon cycle. We can compare it to the northern boreal forest or more southern temperate ones. We can also look how different forestry actions affect the forest. We can assess in definite numbers how the forest feels when it's cold or hot or dry or snow or no snow. And finally, using all this knowledge, we can predict what's going to happen with our forest if the weather keeps changing the way it does now. Thank you.